So welcome everyone to our Scripps Technical Forum. This is an opportunity to connect with partners from around the disciplines to have a technical conversation and connect in ways that will hopefully help us all solve a lot more problems. So I'll start with a brief housekeeping on the Zoom webinar. So we will be using the Q&A and the chat for any questions. At the end of the presentations, we will have Q&A time. So please be welcome to add your questions into the Q&A or the chat, or raise your hand and come on audio to share your questions. You can put in questions during the presentation and we'll have some time after to speak to those. And I will introduce our two speakers shortly, but we will also share everyone's information out afterwards if you want to follow up with more conversation as well. And this is just a little bit about Technical Forum managers, myself, Vanessa Scott, and Douglas Alden. We would love to continue to expand the Technical Forum. So if you yourself have an idea based on this presentation or based on work you're doing, and you'd love to share a cool case study with a partner or circle up with different Scripps groups on a technical aspect, we would love to support you in that. So please reach out if you have an interesting idea. All right, and I will stop sharing and then I'll introduce our two speakers today. So we have Eric, who is the Senior Optical Oceanographer with Seabird Scientific. He's been with Seabird for almost 5 years after spending 7 years doing Arctic research in Canada with the Université Laval. He achieved his PhD in oceanography from the University of Washington in 2012. Eric specializes in optical oceanography and has academic degrees and experience in electrical engineering and software engineering. So welcome, Eric. And then we also have Marnie. Marnie is the Research Facilities Coordinator with Oregon State University. Marnie has, at Oregon State University's Hatfield Marine Science Center. She holds an MS in Marine Sciences from Western Washington University and a BS in Biology from UC San Diego. And she has over 2 decades of experience in oceanographic research and instrumentation. So thank you, Marnie and Eric, for being here today, and I will turn it over to you to start your awesome case study.
All right. Thank you so much, Cannon, and thanks everybody for joining us today. I'm gonna try to share here. How's that working? Look okay?
Looks great.
Okay, thanks. Yeah, so hi everybody, my name is Marnie. I am a proud UC San Diego alum, and really happy to be here and talk about our new coastal monitoring station. It is still new. I have a great team that I get to work with. I want to acknowledge them. They help me with everything from how to pump water up into our CMS station without destroying delicate diatom chains, to cleaning up my terrible Python code, to getting our metadata into climate forecast conventions. So I really can't say enough about our awesome team of their state and federal and industry partners, and I'm really so lucky to get to work with them all. Let's see if I can get. It's not going. I'm going to get my slide to move to the next one. Okay. Sorry, technical difficulties here. Here we go. Okay. So the Coastal Monitoring Station, we're here at Hatfield Marine Science Center in Newport, Oregon. And we're on the Oregon coast. We're about halfway, for those of you who aren't here on the west coast of the US, we're kind of halfway between the Columbia River and Cape Blanco. And we're also sometimes known as NH0 because we're kind of at the base, the land margin of the Newport hydrographic line, if you've heard of the NH line in your studies. And there's a lot going on here in Newport in our estuary. We get a huge amount of seawater coming in twice a day with our high tides. The tidal influence in the Yaquina River goes up the river about 20 kilometers. And mixes, we have a lot of tidal mixing here in these basins here. And there's a lot of human activity as well. For about 10,000 years, the Yaquina people made a really great living off the abundant shellfish and seafood and kelp species here in our estuary. They were forcibly removed to a reservation a few miles upriver in the 1800s. So there's a lot of ways of understanding water quality in our estuary, and I want to acknowledge that they were the first to do it. These days, you can see here we have downtown Newport. There's also the Coast Guard fleet. We've got the Newport fishing fleet here. The NOAA fleet is also down here, and we have the Oregon Coast Aquarium. Here is our little 50-acre campus of Hatfield, and for about 40 or more years, we've been pumping seawater at high tide into our state and federal research labs, and also our visitor center, where we have animal exhibits and things that need seawater. So as you can imagine, we can only pump at high tide, and it's really important to keep track of the salinity in the wintertime. We can only pump about half an hour a day sometimes because we get so much fresh water from winter storms. So through the years, I forgot to mention also we have, of course, OSU Marine Operations is also right here. And we've all been kind of working together throughout all these years. So through the years, the support for and funding for water quality monitoring here at our little station, this is our little dock here at Hatfield. We haven't had a lot of really great funding, and it's been sporadic at best. So if you were a data scientist looking for, say, a long time series data from our estuary, you would encounter a lot of different metadata and data formats. We're still trying to figure out who was in charge of taking the salinity measurements back in the 80s. Fortunately, Seabird deployed a Lobo mooring back from 07 to 2013, and that data is still online and really awesome data set. It's really well managed, so thank you, Seabird, for continuing to have that up online. And then our longest data set so far was from T-Chris Mochon-Kalura from the EPA. From 2009 to just this year. He deployed a YSI exosonde just off our dock, and unfortunately he was forced to retire this year, and his data has been QA/QC'd and it's up on the EPA website, but because of all the federal funding cuts, we're not sure about the longevity of these types of federally funded data sets. So fortunately, Oregon has stepped in and tried to stabilize funding for our longer term water quality monitoring. And that started in 2021. A big impetus was in 2021 when we declared, our legislature declared a state of emergency for ocean acidification and hypoxia. And I wasn't at Hatfield then, so I was going to let Eric take it away from here and talk about some of the history back in those years.
Hi, I'm Eric Rehm. I'm a senior oceanographer at Seabird Scientific. We're thrilled to be part of this project and help contribute to the understanding of coastal ocean acidification and hypoxia, and of course, the relationship between the two of those. And let's see, let's go ahead and flip to the next slide because I need it for the prompts. So this is just a very quick and overview of kind of how we got to where we are with respect to state funding for largely state funding for the coastal monitoring station. In August 2019, then Governor Kate Brown endorsed an ocean acidification hypoxia action plan. And not too long after the plan was published, specifically to invest in terms of one of the major objectives is to invest in Oregon's monitoring network to document oceanographic and biologic conditions and reestablish oceanographic monitoring, for example, that which was lost by Lobo, to complement a historical time series in the Bay, in Yaquina Bay. And so why would that have even happened? Well, we all know the importance of aquaculture to state economies. So the health of coastal Oregon is well known to the state legislature. As we know, also there have been other climate-based impacts in Oregon. I think you can probably all remember fires in 2020. So in March 2020, after really probably more than a decade of awareness by both the aquaculture community and the legislature in ocean acidification, but also other aspects of climate change, the governor proclaimed a statewide climate emergency. And I think this is what helped propel funding for the OAH action plan. In the sense, it's great to have a plan. There's another thing to have the funding to carry out the oceanographic monitoring that was identified. So in 2021, there was a House bill that allocated funding for the research, monitoring, communication efforts. Just so that you know, EPA, and there were federal efforts that have been going on for some time, probably even before 2015, maybe going back as far as maybe 2009. But in 2021, a report called Measuring Coastal Ocean Acidification Using In Situ Sensors in EPA's National Estuary Program was published. And if you consult that report, you'll see that, one of the National Estuary Program sites highlighted in that report is Tillamook Bay, some hour or two to the north of Newport. So Oregon's coastal environment was also on the federal within the sites of the federal monitoring programs. And that's one reason that they began a monitoring program some time ago. In November 2021, Seabird joined OSU and EPA to help plan what was then called the Hatfield Marine Science Center Climate Monitoring Station. And we brought to the table a grant of some equipment. So we did this partly because we believe in this. It's convenient for us because we actually live in Corvallis, but we still have about a dozen people who live in the Oregon area. We need platforms to carry out some of our own testing. And there's nothing better than climate quality data and monitoring those sensors to help us improve the sensor technology that we provide to projects like this and to oceanographers worldwide. In March 2022, I guess, was technically the OAH project start date. Some additional funding based on another House bill in 2022. And notably, the results noting in that House bill, the results of increasing ocean acidification hypoxia have had far-reaching consequences for both Oregon's ocean ecosystem and the economy, consequences that we as a society are only beginning to understand and quantify. So I think this motivates what we're doing. We're happy to take more questions afterwards, but you can see that we're, for the most of the infrastructure, we're firmly planted on state funding. Go ahead, next slide. So what did we do? Once we sat around the table, in some of the early planning meetings started out with OSU and EPA that already had some instruments in that time series. But basically, from a science perspective is, what are the science questions that we want to talk about? Well, we've talked about that already in terms of understanding ocean acidification. It's impacts on aquaculture and being able to understand what the carbonate system is in an estuary and its related effects on hypoxia. So those are the scientific questions. Then next is, what do we measure? Well, of course, you always have to measure physical properties, salinity, temperature, and depth. And then Seabird and others have made quite an investment and provide sensors for oxygen, chlorophyll, fluorescence, in other words, phytoplankton biomass, optical backscattering, which is another way to get at phytoplankton biomass, but also turbidity, fluorescence of dissolved organic matter, nitrate, which is going to help drive primary production, pH, and aspects of the carbonate chemistry system, pH and flow through PCO2. You might ask, why would we have overlapping instruments? Well, we have an existing time series from a set of YSI zones, and to make those time series with new instruments like the Seabird 37, CTD, and dissolved oxygen, and so on. We'll go over those sensors later. It's good to have overlap, and we all know that. So gaps are not good. Overlap between both different instruments as well as opportunities to change sample rates. So the EPA YSA data records were roughly at a 15-minute, that's meant to be minute, not 15-meter sample rate, 15-minute sample rate. And we felt that higher data rate Seabird measurements could help us oversample tidal cycle phenomena. So for example, stormwater runoff, vessel disturbances. I'm using a cheat sheet over on my left monitor here. Better hydrodynamic modeling. There were PIs who were interested in harmonic analysis and getting better ideas of, the turbidity load estimates and so on. So obviously sample rate can help you discover phenomena. 15 minutes gives you just barely enough to resolve the tidal cycle itself. So that's one of the opportunities also by having overlapping measurements. Next slide. So I'm not going to go over this slide in detail. It can be available, or we can go over it more in the Q&A. But one of the things that we did was sit down and say, well, what should those sample rates be, and how would that? What does that look like? And I think anyone who's been involved with having multiple sensors will have produced a spreadsheet similar to this. It helps you understand both the science, but also the data infrastructure, the power requirements, the longevity of instruments, let's say like a nitrate sensor that has a deuterium lamp that has, a limited lifetime. So you want to say, how long is that lamp going to last? But you can see that our sample rates for, let's say, lightweight instruments, lightweight meaning in terms of power and data, chlorophyll backscattering, and fluorescence of dissolved organic matter, we can sample at 1 hertz, let's say a burst of 5 for every minute. Whereas let's say for temperature, salinity, and the other things on a CFOX, CTD, and oxygen and pH, we could do that every 5 minutes, and gives us, again, this opportunity to observe phenomena that's at a higher rate than, let's say, the existing YSI measurements at 900 seconds or 15 minutes. Next page. And I think it's back to you, Marnie. Yeah, so here's the timeline. I'll let Marnie take it from here.
Yeah, thanks, Eric. Yeah, we had a pretty big influx of some support from the state and some other capital investments. So in 2021, Hatfield was able to kind of rebuild our crumbling dock and pump house, and started, we added a little bit of a tiny little room here for the climate monitoring or coastal monitoring station. And we have something called the iLab here at Hatfield, where we design and build instruments and all sorts of things. And so it's staffed by OSU staff as well as student interns. And they designed and built the room and the winch system, and put a little hole here in the floor to deploy our instruments. And they designed and built the instrument frame as well. They welded and 3D printed and deployed. We finally were able to deploy it in 2024. And you can see we've got some real-time data flowing just last year. And this year we're just starting with outreach efforts. And this talk is part of that. So here's kind of a side view of our dock and the pump house. There's the USDA oyster research cages are out here right next to us. And inside our little room, we have the instrument frame here ready to go. We have our C cables with power and data connected up to a Raspberry Pi logger in here, and an Ethernet cable out to a switch. So we have constant power and data supplied to our instruments. And we also have a test instrument bed. So we have an extra winch here for researchers who want to test their own new instruments. I think we had a question from the audience about low cost prototypes. And we have been deploying things like Francis Chan deployed an oxygen sensor here next so he could compare his data to ours. We've had folks deploying open CTDs and other lower cost instruments and prototypes that folks want to compare to our real-time data. So that's been really fun to help folks with that. And then Eric, do you want to talk about your system here?
Yeah. If you notice that slot in the floor was a rectangle, not a square, that allows two different cages to be deployed. One, which is the coastal monitoring equipment. The second would be any sort of related experimental instruments. They can be self-logging, they can bring their own logger, but obviously Seabird is interested in this because we'll have essentially a well-maintained set of instruments, some of which are Seabird, some of which are not, but to do our own experimental testing. We've contributed to this project some sampling infrastructure that we will use, but is also available to other PIs. And what we wanted this to do is be very flexible and easy to add and remove, particularly serial output instruments. So we can support up to 16 serial output instruments, power them, control them in a way that's publicly accessible through a public through a static IP address. So that's something that we brought to the table. The data is automatically pushed into an S3 bucket. It uses a software as a service system called Mesmo to allow essentially quasi real-time monitoring of the data packets. But the purpose of that software as a service is mostly to make a transition between the data that's output by our serial concentrator and a public Amazon Web Service S3 bucket. And I'm happy to explain more of that in the Q&A if people are interested.
All right. So going kind of underwater, wanted to show you kind of a side view of what it looks like down there. So we have an anchor plate down at the estuary floor with some static lines to prevent the instruments from moving too much around with the tides and current. We keep the instruments about 1 meter off the estuary floor. We are able to move, like Eric was talking about, the second winch system can deploy instruments anywhere in the water column, but we keep ours just 1 meter off the floor. So to take a closer look at these instruments we actually have deployed, we have a YSI exosonde, which is sampling at a 15-minute interval. And this is the same one that was deployed by the EPA since 2009. It has a CTD, takes pH measurements, dissolved oxygen, and it has a couple different fluorometers to measure phytoplankton fluorescence and turbidity. It has, and I guess I shouldn't speak for Eric. Do you want to take over, Eric, to talk about the Seabird sensors?
Sure, since I think there were some specific questions submitted. So the Eco Triplet is a sensor that in this particular configuration allows up to 3 different optical sensors. And it does phyto, and this, though, the one that is part of, or the ones that are part of the climate or coastal monitoring station now, are phytoplankton chlorophyll A fluorescence, fluorescence of dissolved organic matter, and scattering. And you can see it also includes a copper face and wipers as biofouling. This instrument can sample at rates, I think, up to 4, maybe even more if you push it up to maybe even 10 hertz. We're running it at, I think, at 1 minute intervals with I don't know exactly, but the general idea is 1 hertz with a 5 second burst, so that you could get really some small sample statistics out of each burst. There's also a SUNA, which runs less often just due to the cost of the lamp, and probably the time scale of the measurements are not as important to sample at a high rate. So that's sampling at a 5 minute interval. The SUNA is basically UV, ultraviolet lamp and an ultraviolet spectrometer looking at the absorption due to both salt water, but more importantly, due to nitrate. And nitrate is resolved as a part of that. And coming soon is a Seabird Seafox, which is basically an SBE 37 CTD with an optical dissolved oxygen sensor, the SBE 63, as well as our CFET, which is a pH technology based on a transistor, ISFET transistor technology. And also happy to answer more questions about the shallow Seafox in the Q&A.
Okay. Yeah, so you may have noticed this other white tube here, and that is our sampling well for the imaging flow cytobot, or IFCB. We did manage to deploy this for a month this summer. Since this year is our first year of deploying all of our instruments, we were very happy to at least get Maria Kavanaugh's IFCB from OSU, from the College of Earth, Ocean, and Atmospheric Sciences. And so that well that we were showing in that previous slide is our sampling well. We have this enormous peristaltic pump that's running in here that is able to delicately pull water up from 1 meter all the way up to the dock. And we did manage to not destroy our delicate diatom chains. We're really concerned about that, which is why we use the peristaltic pump for that. It's like the biggest peristaltic pump you've ever seen. So that was a really cool result, and we're really hoping to purchase our own when the world is no longer upside down. We have some better funding to purchase an IFCB dedicated just for the coastal monitoring station for like HAB monitoring, harmful algal bloom monitoring. I wanted to give a shout out to Clarissa Anderson at UC San Diego for her work with the IFCB network in California. They were able to show some really compelling evidence of harmful algal blooms kind of like slowly making its way north based on some of the data coming from the IFCBs. And we hope to be maybe the next point north of California, because as far as we know right now, there aren't any dedicated IFCBs deployed in Washington or Oregon. So we're working on that, and that's our next big move. And then we also had the Percolator was deployed most recently here in the CMS from July till just last week. Our Percolator is run by Steve Pasella with the EPA. It takes high frequency carbonate chemistry observations. And we, unfortunately, with the government shutdown, they had to unplug, they literally had to unplug the Percolator last week. But we got some great preliminary data from Steve. We had some really high PCO2 values in August, as well as obviously really low pH measurements. And it turned out our pH measurements from the YSI sonde correlated really well with the calculated pH from the Percolator. So I think we had some questions from the audience about our carbonate chemistry, if we were making those measurements. And so we were until last week. And we hope to, as soon as the government opens again, we hope to get that program going again, because it's really valuable data. So a little bit about our data architecture and where the data goes. Hopefully Jasmine Nahorniak is in the audience and can and answer other questions about our real-time data visualization system called Coriolis. But in general, we have the instruments in the water send their data via serial cables up to a Raspberry Pi that we have there on the dock. The Raspberry Pi has this open source logging software called OpenRVDAS. And at that point, right there in the Pi, we read in the data, it gets parsed and transformed, calibration coefficients are applied, and then we send the data out to our Oregon State Data Center in Salem. And OSU has some virtual machines there that host our web services and our website, our ERDAP, as well as the database for Coriolis. And that's where we can access our real-time data. So our website is up. It's still kind of under construction, but it has a lot of the same information we're covering in this talk. We have the QR code for the website at the end of this talk. And here's some examples of our real-time data through Coriolis. We have our, here's an example. We always have tide in black, or it's also just the depth sensor from our YSI sonde. We have oxygen, pH, salinity, and temperature. And all the other parameters are also all available in real time. We also have nitrate and all the fluorometry data. I don't have that on this slide. But we also have customizable plots through Coriolis. A lot of this software is also under construction. I think there's going to be a new version of it coming out this fall. But currently you can visualize, I think, about 3 weeks of data and choose your parameters that you want to plot over time, which is really nice. And then we also have our downloadable data on an ERDAP. We only recently got it into a climate forecast convention, and we're getting, I think this month, Jazz said we're getting the back end format of the data harvester ready, so that it can go into repos like IOOS, and here in the Northwest we call it Nanus. And Eric, I don't know if you wanted to say anything more about the CF conventions or anything like that.
No, just for those climate forecast conventions, really just a set of naming conventions, which allows essentially universal discovery of data without having to open up a metadata page and say, okay, it's lat in this file and it's latitude in that file, or and so on. So it makes particularly with formats that are self-describing like NetCDF, it helps essentially not only humans but also software be able to operate a lot more efficiently. And you can Google just CF format. It's something that everyone I think should be aware of. And if you're ever planning a system, make sure that you pay attention to that early and often, because that otherwise you'll have to do it later. But it's part of what I would call climate quality data, and we often think of quality in terms of and something Marnie will go over shortly is QA, and let's say the sample rate that we talked about before, the precision or accuracy of the instruments. But if the data isn't findable, as in I think the FAIR principles findable, then all that other stuff doesn't matter.
Yeah, we've had lots of conversations about it's always better to start these things early, so that you don't have to go back 20 years later after you already have this huge data set and then fix your metadata, right? So so there was a question about real-time QA/QC, which is very important. I'm glad you all were asking these questions. So since we're just in the first stages of collecting data, we really wanted to get this right now so that we're not doing all of this post hoc. So right now we are we have pretty good overlap with Cortod required tests. Folks might be familiar with Cortod. I have the acronym down here at the bottom of the slide, and then the Coriolis, which is our real-time data system, has almost all the same required tests that Cortod has. Obviously, we don't have location unless we have some, a tsunami or something. We're really hoping we don't require, because we're not planning on moving off of the dock. So we have the same gap syntax and gross range tests. And Coriolis also adds another sensor test, kind of like talks about the status of a sensor. Is it online? Is it being calibrated? Is it in testing? And then I think the Cortod climatology test is the same as what Coriolis has for the global range test, which is basically just saying, does this data fall within the range for all seasons for this location, this specific location? And then the gross range, you all are probably familiar with, is it within the what's possible for the instrument, the detector, the calibration range? Anything you'd like to add to that, Eric?
Oh, just a quick note, in case you're not familiar, Cortod, it's a funny word, but it's quality assurance of real-time oceanographic data. So it actually makes sort of sense. Quality assurance of real-time oceanographic data.
Mm-hmm.
Oh, and by the way,
Cool.
our next generation eco sensors will have some Cortod like gross range checks in them too. So what's interesting is we're starting to push QA into instruments.
Yeah, very cool. All right, let's see. So I was going to go over some, just some actual data that we've collected since we started this year. You all, I'm sure, are familiar with the earthquake that happened in July in Russia. And we all, I think, depending on where you were on the coast, we were all bracing ourselves for this huge tsunami. Here in Newport, we got about a 6-inch tsunami that arrived around midnight local time. And I wasn't really expecting anything, but it turned out our sensors picked up this little 6-inch increase in the water depths, and then our fluorometers also picked it up. We think it was probably just the nepheloid layer kind of being disturbed by the sashing or sloshing of the water. But the really interesting thing I thought was that the sashing continued for almost a week. Down here in the second plot, we have the depth data, and these little wobbles in the depths continued for almost 7 days. So that was a really interesting kind of just real-time thing that we weren't expecting to see, but picked up in our instruments. And then also the spring transition this year, we noticed we kind of had this winter pattern all into the spring, and then all of a sudden we started getting these huge drops in oxygen just at high tide, which I was like, is that real? Is that a real thing, or is it just coincidence? So I started looking back at some of the other data off our coast here, and sure enough, just a few days before we noticed those drops in oxygen at high tide, we also noticed from the HF radar current meters that COSRO has, the COSRO lab in COS here at OSU. They monitor the ocean surface currents, and it was just from the 11th to the 12th, you can really see the direction of the surface currents change to southward. And sure enough, that's when the upwelling started, because then we could see on the OOI moorings, our shelf bottom mooring picked up this huge drop in oxygen that continued all summer long. And those all happened within about like 5 days of each other. So that was another kind of cool little bit of data that we saw and kind of in real time. So I also wanted to mention, that data came from that bottom oxygen shelf data came from OOI. I worked with them for about 7 years, and this year is the first time they just brought back all of these instruments off our coast, and they did not redeploy them because of the federal cuts. So it's even more incumbent, I think, on us with state and private funding and industry funding to continue this monitoring, because these types of large federally funded installations are disappearing. And so we no longer have this data coming from our coast moorings. So coming into a little more about our who we know has been using the data. We have some state and federal partners here at Hatfield who have been using the data. I think I mentioned the USDA shellfish research, the oyster research hatchery. They have cages out here right next to our the CMS installation. We have some of the Northwest Fisheries Science Center juvenile groundfish tanks using this data in there because they're using our water, obviously, that we pump. And yeah, outreach K through 12. We hosted an MBARI workshop. We have our visitor center that has our gorgeous giant Pacific octopus. And yeah, so our facilities folks are always monitoring that because they're pumping from the dock into all of these different labs, including our visitor center, which is really important for outreach right now. So we're really trying to lean into outreach, especially in light of all the federal funding cuts. We want voters to understand what's happening out in our waters and why it's important. So we're working on a new exhibit where we're going to have a replica of our instruments here. We're going to have a live webcam of the estuary bottom that folks can play with a little joystick and zoom and pan in on critters in the cage. And then also kind of a new software that we're designing. A couple different little like games that people can play to engage with ocean acidification and hypoxia. The impacts on our local oyster farmers. We have an oyster farm just like half a mile up the river from here. And then also on the hypoxia effects on our local crab industry, which is major economic impacts on both industries. And then other potential users are, obviously I mentioned the crab harvest and oyster hatcheries. We hope to get the IFC once we have a longer term IFCB installation, helping with the Oregon Department of Ag and also just general monitoring of these species that are causing harmful algal blooms. And we have local folks who come and try to they dig for shellfish right here in our flats, which is always entertaining to watch. And we have lots of visitors who use our tide and weather data as well. I threw this in here just because probably many of you on the call have to deal with biofouling. So here's some pictures of the barnacles, and we got nailed by herring eggs this April during that 1 week that they decided to lay their eggs. And you can really see here here's the triplet. You can see where I had put the copper tape on here. There's no barnacles there, and then there's just barnacles everywhere else. And here's our copper guard on the YSI, and everywhere else is just like covered in barnacles. So I don't know if we all obviously we do have the copper faces and the bio wipers that are provided by like Seabird and YSI. They're really helpful. It's amazing. Like usually those are the only spots where we don't get just like completely covered in biofouling. So and I think Eric, you mentioned you have some new developments with some of your instruments for biofouling.
Yeah, we're going to be doing some experimenting with UV based biofouling as part of our efforts there.
Yeah, looking forward to that. So yeah, I guess we're kind of at the end of our talk. I wanted to really thank everybody for the questions that you sent in. And I wanted to make sure that Eric and I answered all of your questions, either in our slides or if there's anything here that we didn't cover, please put it in the chat, or we can talk about it offline. Feel free to email me or Eric. And yeah, just really thank everybody for coming. We're still developing, and we want to make sure this is a data that's available for everyone, and make it a really like a community effort here, because it's for everyone. It's not just for those of us in the ivory tower. And that's it. Yeah. So any other questions? We can switch to if you're getting questions in the chat, or you want to take over from here?
Great. Thank you so much for the awesome talk. Yeah, so everyone in the audience, feel free to share any questions in the Q&A or chat. Apologies that the chat was disabled in the beginning. That was a surprise. We also have Jasmine here. So if there are Coriolis questions, we'd love to have you join us, Jasmine. All right, we've got some questions coming in. So from Charles, many academic labs face resource limitations while industry brings tools, data, infrastructures, and long-term service capacity. From your perspective, what are the best ways for industry to show it's here to help and not just sell equipment, but really support the science?
Well, this is Eric from Seabird, since it was best ways for industry to show that they're here to help. I mean, I think the climate, or should I say coastal monitoring station, is a perfect example. You know, we made an investment by granting 2 CFOXs, 2 SUNAs, 2 ECOs to the system. That's a substantial amount of hardware, but in return, we have a place where we, you know, have a reliable, essentially reference sensor. It's a well-maintained climate quality record. We couldn't develop that really on our own. I mean, it would be impossible if you think about the siting issues and permitting and maintenance. You know, it would cost us far, far, far more to develop our own, you know, long-term reference, you know, sensor setup to which we could, let's say, compare either when we're trying to solve problems for customers, or trying to innovate, or trying to test out new designs. You know, this is a gold mine for us. So I would encourage, you know, industrial people to say, when you consider, let's say, field testing your equipment, and all of us who make equipment have an obligation, I think, to put them in the water, not just test them on the bench, put them in the water, put them in the water where the data that they collect can be, you know, checked against whatever, against, you know, reference instruments, but also put them in places that encourage and support collaborations, especially in a funding restricted environment. I hope that answers the question, Charles.
Awesome. Thank you. Yeah, maybe we had some questions submitted for the webinar, a couple that were sort of around citizen science. And so maybe you two could talk a little bit about engaging with and sharing those citizen science organizations or data sets out with different groups.
Oh, yeah. I guess I could talk a little bit about that. As far as like citizen science, you know, this data is public, and it's on our website, and you can download it, and it's available for everyone. And we also, I think I mentioned we worked with, we have K through 12 teachers and workshops and community college folks that come in, and some teachers have already been using our data for some of their curricula, which is really cool as well. I don't know, Eric, do you have any other comments on that, or?
Oh, I just say that good data is always the starting point. You know, actionable data products, sometimes that's the raw data, but most often. So it's a you know, some sort of processed data set. So how do we know when a HAB is happening, or we use a model to predict it based on other variables? Well, that may be the you know, what, let's say, an aquaculture and industry person wants to know is, you know, what's my risk of a HAB, or when should I shut down, or et cetera. And so I think this is really just the beginning of the story. Such process data products have That's been the goal of a lot of the regional ocean observing programs. Ours is called NANUS. I think largely run out of the Applied Physics Laboratory at University of Washington. So I think, first of all, more data is better. More data with respect to locations is better, because every one of these coastal embayments along the coast of Oregon has an economic impact. And so the hope is that this kind of thing with respect to actionable information for both citizens and industry, is replicated.
Yeah, absolutely.
Great.
I'll just
Okay.
speak real quick. There was a thing in there about 24 hertz, and there's no magic sampling rate. As a scientist, you have to sit down and see what you would like to discover. Interestingly, if you're looking at standing waves in an estuary, something you might not think about until you see the obvious, that there was an earthquake that caused a tsunami that caused a standing wave that, in fact, you might not have even thought about in your sampling plan. So I think we all learn from experience, but high resolution, once per minute turbidity data can tell you a lot more than once every 15 minutes. Now imagine if that had been a bigger tsunami that had larger physical or economic impact. If you don't plan for this ahead of time, you may not be able to resolve phenomena. But it's a tough scientific question that you need to decide or think about, is what scientific phenomenon from a timescale perspective am I trying to resolve, and that's going to guide you with respect to your sample rates.
Awesome. All right. Any other questions from our audience? I have one question while we wait for anyone to get in their last minute questions, particularly with the slide up. I know we have some entrepreneurial minds in the audience and around Scripps. So what is the best way to connect with you both and maybe start collaboration or brainstorming ideas? Are there particular areas that you're looking for to solve some problems that exist?
Yeah. I don't think yeah. Yeah, absolutely. Please reach out to me. The QR code's there to find our website, or email me or Eric. We're open to collaboration right now. We're kind of in a, we're getting into the rhythm of, I think there was a question about calibrations and how often do we service things like the SUNA. That was a great question. I have a lot of experience working with SUNAs out on the OOI moorings. So for those, we would only calibrate them with DI water with a little parafilm trick once every 6 months. I'm trying to do that more often with the one here because it's right on the dock. But yeah, if folks have issues like that where where you've kind of optimized how often you service instruments, or if you want to share data, or yeah, anything like that, please reach out. I'm happy to. That's kind of where we're at right now, is how do we kind of optimize things like sampling rates and calibration, how often do we calibrate, because you have to take things offline and then you have a hole in your data gap, a gap in your time series. So anything like that, if people have recommendations or want to collaborate, please reach out.
Just a quick aside, that's one reason why we kind of did a Noah's Ark of instruments from Seabird. There are 2 sea foxes, 2 triplets, 2 SUNAs, because that allowed us to change out one set, or at least individual instruments, without losing the time series, because we know that gaps in time series are hard. I mean, you can't replace the data, and it takes you a long time into the future to let's say to hindcast, or you may never be able to do it depending on the phenomena of interest. So that was part of why Seabird made the commitment to do 2 animals instead of 1.
Yeah, we really appreciate that.
Great. We have one more question from Charles. Are you already thinking of adding, replacing instruments and involving the station with new needs that you are identifying now? So are you kind of looking ahead into what the station could develop into?
Yeah, absolutely. Thank you, Charles, for that. I don't think I mentioned I did mention our next move is to have a dedicated IFCB, but I'd also like next year to add we have a weather station that we're ready to mount right now with wind speed, direction, humidity, temperature, barometer, and stuff like that. But then we also have the percolator has the ability to run a tube up. So we're going to try to have an air tube up next to the weather station. So our next a big thing is to try to get CO2 flux between the water and the air using the CO2 data and the wind data. So that's something that's coming in 2026, we're hoping. And the IFCB will probably be later because it'll take longer to get the funding for that.
And Seabird is always innovating and evolving our set of instruments. And again, from our perspective, being able to essentially pair up new instruments or fixed instruments or innovations with existing instruments, again, is really important to us. And this is a gold mine for us to be able to do that. Now, whether some of those innovations make it into the coastal monitoring station or not, but I can't help but think that if we have a new and improved sensor that we would like to be part, or that the coastal monitoring station thinks should be part of the climate record, or the PIs think is part of the record, expanding that, or expanding, let's say, dynamic range of an instrument, or its better signal to noise ratio that allows you to see phenomena. We're happy to have that discussion.
Great. Thank you so much. All right. Charles is interested in helping with large diatom chains. So hopefully we will connect you after the webinar. So thank you so much, Eric and Marnie, for this great talk. The recording will be available after, and I will send it out to everyone who RSVP'd. Thank you, audience, for your great questions. And we'll be sure to stay in touch. And once again, let me know if you all have ideas for another Scripps Technical Forum. All right.
All right,
Thanks so
everybody.
much.
Thank you, everyone, for coming.
Bye.
I appreciate it.